Hello folks, welcome to The Age of Asparagus and part 6 of making a 3D top-down shooter in Godot. By the end of this video we'll have a simple state machine that will allow our enemies to turn red and take lunging attacks at the player when they get too close. Then take a little rest before they continue their hunt. I apologize for the length of this video. In the future I'll try to keep the episodes under 20 minutes if I can. Alright, so the first thing I want to do, just to make testing a little easier, is I'm going to go delete some of our waves here. So let's delete the middle wave. I can just delete here. And wave 1, I'm going to only make it 2 enemies and just 1 second each. So they happen fast. If we want some slow enemies to test on, we can do that. And wave 2 will be the ridiculous number. Let's not do 50 though. Oops. Let's just do 20 so we don't crash and slow down the computer. Now, we'd probably not have a real wave like this in the game, but it's nice for testing and it should pop out any weird bugs we have pretty quickly. Alright, so if we want the player and enemies to overlap, we'll need to start using some of these collision layers and masks. So let's set some up to make this easier for us. We're going to go to the project settings, and in the general tab we'll scroll all the way down to the bottom, and in the 3D physics layers, let's create a world layer, and I'm just tabbing between fields here, a player layer and an enemy layer. Okay, we can close that. And let's select the player, and in the player's physics body, we're going to put the player on the player layer. If you hover over a layer, you should be able to see the layer names we gave them, but I can't. I think I need to restart Godot to have that take effect. So I'm going to do that now. Let's go project, quit to project list, save that, and let's get back in our project, see if that worked. Okay, so we're going to put the player on the player layer and take it off the world layer. Again, hovering over will let you see the name of the layer, or you can just click here, which is a little bit easier. And we'll put the enemies. Let's open up the enemy scene, and we'll select the enemy, and we'll put the enemy on the enemy layer and take it off the world layer. And let's just see what happens here. All right. It's kind of working. Obviously the enemies are not interfering with each other, which could be kind of hilarious on the second layer because it's going to turn into this giant, cool slime thing. That's awesome. But we do have the enemies coming in. And notice how they don't overlap with our player. They just come within actually 1 unit of the player. And that's because in the enemy script here, we tell it, once you get within 1, then stop moving or go to the next node, and if they're on the last node, then they're done. So they only ever do come within 1 unit of our player. And you could change this if you wanted to 0.5, and if you take a look, then they're just going to come in a little bit closer. So let's leave that at 1 though. You can maybe make this an exported variable if you wanted to fiddle with it. So we do want the enemies to collide with each other, so let's change the mask for the enemies and add the enemies layer. So here are the layers that the object is on, and these are the layers that it interacts with, that it detects collisions with. So obviously we want to detect collisions with the world because we want it to move and slide around obstacles. However, it kind of won't go into obstacles anyway because of our pathfinding. But we do want it to also interact with enemies. So now if we try it, they should pop away. Let's go to that second group there, and yes, they're not overlapping anymore. Perfect. So next, we want to have the enemies attack the player once the player comes within a certain radius of the enemy. So we're going to add a new area to the enemy. Let's add a child node. It'll be a 3D area, also known in the rest of the world as a volume. And we'll give it a collision shape. This collision shape, I'm going to use a cylinder. So let's add a new shape resource to it, and let's do a new cylinder shape. I'm going to hit 1. And move this guy up to about the middle, and hit 7 to go to top view here. And I'm going to move this out about 3 units. So 3 units beyond. Is that going to be too far? That might be too far. We can change that later. And just look around to make sure that makes sense. Yep. When the player enters this area, our enemy is going to do a lunge attack. Okay, let's connect to the signal for that area. When a body enters it, we'll connect that to our enemy script. And for now, let's just test it out. Let's just print something entered my attack radius. And maybe we can give it the name. the body there. Let's give this a better name too than area. We'll call this attack radius, or we could call it attack area, attack radius, sure. And let's see if that's working here. Oh yeah. Oh, things definitely, it's detecting it. Again, boop, boop, boop. Yep, it's even detecting the CSG box here. You can see, so when it gets within that area. So now let's go back to the enemy script, and we're just going to make sure the body that is entering that area is a player. So we'll go if body equals player, and we already have a reference to the player at the top of the script right here. Oops, we want double equals there. We can get rid of this. Then we're gonna attack the player. So let's create a variable called attacking, and we'll set that to true if they enter. So at the top of the script here, we can create a new variable called attacking, and we'll set it equal to true. We'll set it equal to false to start when they're searching around, and then we'll set it equal to true once the player enters the attack radius. So because I renamed the area after I created the signal function, I don't like that name because what area was entered? So let's change this to on attack radius body entered, and we'll have to reconnect that signal. So if I click on the little signal here, it'll show up right here. Let's can I edit it? Ooh, I can right click it, edit, and then I can choose. I do want the enemy script, but that's not what I want it called. I want it called this seems like a bad way to do it. It's just asking for some typos. So let's just delete that one. Disconnect. Body entered. We're going to connect again. And on attack radius body entered. Yeah, that's the one we wanted, right? On the enemy script, that's the name. Let's connect. And I think if there was a typo, it would have made a new function down below it, but it didn't, so we renamed it correctly. So now if it's attacking, let's go back up into our physics process where the enemy is moving. And for now, let's just stop the character. If it's going to attack, we're going to pause it. So I'm going to tab this in, and I'm just going to have another if statement here. So if attacking, then we'll just print attack. Otherwise, we'll continue our regular movement to seek out the player. So he should stop moving when we enter the area. Let's see. Yep, and then he attacks. Perfect. Okay, so they paused, and we'll do the lunge attack, but we're going to do that in a moment because it's a little more complicated. But after they pause, they never stop pausing. They never stop attacking. So they never start seeking out the player again. So let's add a timer, an attack timer. It's kind of like how long the enemy has to rest for before it can start moving again and attacking again. So let's just add a new timer. And we'll call this one attack timer. And we should probably at this point rename our other timer. So let's rename that one to path update timer. Path update timer. This is the one where whenever this timer times out, it updates the pathfinding. Okay, let's get rid of that old function name too. We'll reconnect to the path update with that new method name. Yep. On the enemy. Let's connect. So now there's nothing in here. Originally it was this code, so I'm going to cut that out and place it in our new path update timer timeout, and we can get rid of this because we're not using that anymore. Control S, save in here, and it's looking good. Okay, let's go back to our attack timer, and we're going to connect to a signal, connect to its timeout signal, on the enemy, and when our attack timer times out, we're going to set attacking to false so that the enemy can start pathfinding and moving again. So let's set up our attack timer. If we go to the inspector over here, I think let's start at 2 seconds. So after they attack, they'll wait for 2 seconds, and we want it to be a one shot. Once the timer runs down, then we don't need the timer anymore until it attacks. Once it attacks is when we want to start the attack timer. So we should probably do that now. So we're going to need a reference to this timer at the top. Call this one our attack timer, and we'll set it equal to the attack timer. Oops, attack timer. Good. And where do we want to start it? We want to start it when we attack, which is right here. So when a player enters our attack radius, we set attacking to true, and we're going to turn our attack timer. We're going to start it. So let's see if that works. Here's our player. He attacks, he's pausing, and he should start moving again when the timer, 2 seconds. Perfect. So now let's add the lunge. Let's add that jump, the attack. So we're going to need to consider a few things. There's going to be the attack where the enemy charges the player, and then the enemy is going to jump back to their original position. Then they're going to rest for a little bit, and then they're going to start attacking. Now, we could make a whole bunch of Boolean variables like resting equals false and other stuff like that. But that's going to be like 4 Boolean variables, and we'll have to have all sorts of nested if statements and logic. So instead what we're going to do is create a simple state machine. All this is enumeration variable. We'll call it state, and we'll give it 4 states. And let's just do it in the order they happen. So at the beginning, the enemy is seeking, and then the enemy is attacking. And then after they attack, they'll be we'll call it returning, which means they're returning to the position they started at. Then they're going to rest, and then they should go back to seeking again. Okay? So attacking, returning, this is after an attack. And we'll also need a variable to hold their current state. And we want the seeking state to start. So now, in our physics process, where we're telling it to move and do things, instead of having these if statements, like we do there, we're going to use a match, which is similar to a switch statement in other programming languages. And we're going to match our current state. Let's just go through them all. So let's go through state.seeking. And state.seeking, we want to do what we were doing before. So I'm just going to tab that in, and we should be good. After we seek, the other possibility is we could state.attacking. So if we're in the attacking state, so what it's doing here, by the way, is it's checking this variable, and then if it equals this value, then it'll do this code. If it equals this value, it'll do that code. And these are actually, in the background, I believe these are just integers. So this might be 0, 1, 2, 3. But we don't want to use numbers. This allows us to use something much more meaningful in our code and way easier to read. So, and if we're in the attacking state, we can just print attack for now. And let's add the other state. So I'm going to copy that and paste for our other states, which are returning. Can I get autocomplete? Beauty. And resting, right? Yeah. So I'll say I'm going back, and I'll just say resting here. Okay. So let's use some of these now, because we no longer have an attacking variable, as it can see there. So there's one of them. We don't want to set attacking to true now when the player enters the enemy's attack radius. Instead, we want to set our current state to be attacking. And as well, we don't want to make attacking equals false. That doesn't even make sense here anymore, because instead, when our timer goes out, that means our current state can be seeking. Seeking? Is that what I called it? Yeah, seeking. So after our timer goes out, it can start looking for the player again. Oh my gosh. There we go. Okay. So now we should be going between attacking and seeking. And although everything should be the same, let's just make sure I didn't break anything doing that. Okay, so it's attacking, he pauses, and now he's seeking again. Attacking, pauses, seeking. Okay, good. Now, it doesn't actually say seeking because that's the only one we didn't actually have any output, but we saw them seeking, so that's some nice confirmation. All right, now for the awesome fun part, let's do the lunge. Let's do that attack. So now, during attacking, instead of just pausing, and we can get rid of that, we know that's working, let's create a new move and attack. So this is like just going to be, it's going to use move and slide, but we'll put the code in its own method. So I'm going to copy that. We'll create a new function called move and attack. And here what we're going to do is we're basically going to do this code here. We're going to do a little vector subtraction to get a variable, an attack vector that goes from the enemy to the player. And then we're just going to move in that direction, but we're going to move faster than the normal speed. So we'll move like 5 times faster. In fact, let's set that up right here. So we have a speed variable. Let's create a new variable called, what will we call it? Attack speed multiplier. And we'll set it equal to 5 to start, and we can fine tune that to get the attack motion we want later. So actually, you know what? Let's just copy this code, because it's going to be very similar, and we'll put it in our move and attack. I'm going to shift tab to get that back. I'm not going to call this direction though. I'm going to call this attack vector. And I'm going to be a little better here in naming these variables. So we have the attack. Let's get rid of this. Let's get rid of that. Actually, we didn't need much of that, did we? So our attack vector is going to be from the player's position. So we can go player.globalTransform.origin. So our target minus our current position should give us an attack vector from the enemy to the player. And this is a little more clear here now. So I'm going to create another variable called direction. And it's also a vector 3. And it's just going to be our attack vector normalized. Vector dot normalized. Good. And then I'm also going to have another variable called distance. And this is just going to be a scalar value, which will be the attack vector dot length. So that's how far away the player is. This is the direction of the player. And this is both of them. Because as you remember, I hope, from the film, a vector has both direction and magnitude. And we can just print just a sanity check here, and we'll just say I'm this far away from my target. And the target is going to be the player's position, or the distance here. And I gotta have a comma here to print multiple things. And then we're going to move and slide. Just like before, in the direction, we don't need to normalize it because direction already is normalized, times the speed, and now we're just going to multiply it by the attack speed multiplier. So it should be super fast. Okay, so what are we expecting to happen here? We'll test it. They're going to go into the attacking mode, and then when they're in the attacking state, they'll move and attack. This will run. They'll lunge towards the player really quickly, and then they'll get stuck in this state, and they'll just constantly be attacking the player really fast. Let's see. Yep. Oh my, whoa! Okay, and they're, oh wow. And they're attacking his head as well. They become his hat. Okay, so we should deal with those two things. Let's go to the level, and we'll go to the 3D view here. So one of the issues we have is that if let's just temporarily drop an enemy onto our scene here, is the origin of the enemy is down at its base, and the origin of the player is up here by its eyes. So the attack vector is actually from the origin of the enemy to the origin of the player, which you can see is going to be up in the air. So as it does that, and then of course it collides, and it's got a rounded bottom and a rounded top, and I don't know, ends up in his head. Actually, it doesn't collide with the player, so it just ends up in his head. So let's move the origin of the enemy up into the same spot as we have on the player. So you know what, let's go to the player. We'll go to the player scene, and just make sure its position here is 1.428. Let's just set this to 1. You know what? Let's go to front view. And yeah, see, it's still going below the ground plane a little bit. So if we go to the player, let's set it to 1.5, and that should be perfectly sitting on top here. So that's good. I'm going to save that. We'll go to the enemy, and we'll move the enemy up on the Y position to 1.5. But now we're going to have to move its mesh and everything down. So let's just delete the transform translation there on the mesh instance. Same thing with the collision shape. We'll set that to 0. The attack radius is good, but the collision shape here, let's expand the transform and set that to 0 too. Okay, so everything looks fine now, and let's just make sure we don't attack heads anymore. Yep, don't attack heads. Attack the player immediately and aggressively. Oh, what happened to that guy? They ran away and got stuck, and now they're... Oh, there we go. Okay. Okay, so now we need to switch to the returning state and then finally resting. So let's go back to the enemy script, and to return to the original position, we're actually going to have to save that position. So let's create a new variable here. We're going to create 2. Instead of directly attacking the player, we're going to create a variable that is the attack target. So we'll say attack target, and that's just going to be a vector 3. And we're also going to have our return target, and that is going to be a vector 3 as well. Okay, so now instead of attacking the player directly, where we do here, we're going to attack whatever our attack target is. And our attack target already is a vector 3. So let's go attack target minus our the enemy's position. And we'll set the attack target when we are attacking. So let's do that right here. Our attack timer starts. We set the state to attacking. And let's set our attack target as well. And we're going to set that to the player, which we already have a reference to, dot global transform dot origin. Beep, origin. Good. Okay. So we're attacking the target. We didn't really change much, but let's just make sure the bad guys still attack us. Oh yeah, they do attack us. Good. So we don't want them to move and attack forever. We want them to move and attack here, and once they've reached the player, we want them to head back. So let's check the distance. If distance is less than 1, then we've reached our destination. So if we're within 1 of the player, which means there'll be a little bit of overlap, then we can consider ourselves successful. And we're going to change our state. Whoopsie, we're going to change the current state to returning. Okay, that's great. So currently what happens when it's returning, it just says I'm going back. So they attack, and then it just yells I'm going back. Sure, but it's never going to do anything else after that. It's just stuck here and not moving anymore. So what do we want to do when it's returning? Well, actually, I want to attack again, but this time I'm going to kind of do that attack motion towards our return target. So let's set our return target here. So if the distance is less than 1, then we're done attacking. We're going to say we're returning, and we're going to set a new attack target. This time it's going to be our return target. So it's almost like it's going to be attacking back where it started from. Okay? Now, if we do this again, we need to know what state we're in. Like, are we attacking or are we already returning? Because if we're returning and then we get to our return position, it's just going to say, well, I'm returning again. Let's keep returning forever. So let's have another match here, and we'll check our current state. So if we're in state attacking, then we'll do the things we want, which is switch to the returning state and give ourselves a new target. But if we're in the state returning, so we've reached our destination, but in this case our destination is the return target because we're in the returning state, then we'll be coming through here. We've reached the return target, so now we want to set our current state to what comes after returning. We want to be in resting, and once we're in resting, what happens when we're resting? It's just going to print resting, but it should come out of the resting state when the attack timer finishes. So then we're going to go back into seeking, and it looks like we have the full loop now. There's just one thing. We don't actually start our attack timer in here. We start it as soon as we attack, so we should probably not do that. We should probably start our attack timer because we don't want, for some reason, if the attack timer times out and sets us into the seeking state before we've actually reached, before we've returned. I don't know if that'll be a problem at all, but I just think like having the logic here. So we're going to set our current state to resting, and then we'll start our attack timer, which is kind of like a rest timer, and we can shorten that if we want to. So let's see if this works. What do we got? What do we got? Oh, he attacked me and he went back. Oh, that was so cool. Why aren't the rest of them moving though? Oh, wow, they're vibrating. They're what is happening? Oh, so crazy stuff's going to happen now if we kill these guys and go to our big test level. Ready? Okay, far away. You should still start seeking me. Why are you not seeking? Oh, they're not seeking. Are they all attacking? This is messed up. Something's messed up. Let's see. They should all start out as seeking. One of the things is I think our attack radius is too big. So let's go to the enemy, and I'm going to hit 7 to go to top view here. And I just want the attack radius. What's going on? Okay, I want snap on. That doesn't matter for now. Let's go to attack timer. Sorry, let's go to attack radius, the collision shape there, and I want it to be like 1.5 units. Right where the gizmo is. That's perfect. So let's try that. Get it. How does he appear so fast? And why aren't they moving? I'm still not sure why they're not moving. Were they moving before? They're definitely trying to get... They're stuck. Oh, they're attacking though. They're definitely attacking, but they are... We seem to have broken the pathfinding. Oh, wow. So one of the problems here we're having is that because they can't overlap with each other, they're colliding with each other, they're all trying to get back to their return positions, but they can't because they're getting in each other's way. So what we're going to need to do to fix that is allow them to overlap when they attack. But I feel like we have another issue here we need to do before we deal with that. So let's go back to our level, and our first wave, I'm just going to set it back to 2 seconds, and I'm going to run it and get out of the way. Why is he... Oh, you know what? We added that enemy. That was confusing me. Okay, Get out of the way, enemy. Now, let me get out of the way. Are you seeking? You seem to not be able to seek anymore. I think we're going to have to fix our seeking issue. When I change the origin of the enemy, that may have messed up our pathfinding a little bit. And if we go back to our level and click on our navigation mesh, notice our navigation mesh is really close to the ground. Now our player's origin is quite a ways off the ground, our enemy's origin, and I can just drop a temporary enemy into our level again. You can see the enemy's origin is there, and the navigation mesh is way down here. And I'm not sure why. Unfortunately, the documentation for the navigation in Godot is, I think it's empty. Let's search help and we'll look up navigation mesh instance. Navigation mesh generator. Ooh, that's neat. Maybe we'll use that later. But let's go to the navigation mesh instance, which is what we're in right now. There's no description, and this navigation mesh, which is right here in all the settings, there's no descriptions for any of this. No description. So it's kind of just, at this point, looking online for help and guessing and checking. So unfortunately I can't point you to any documentation, but I think I know what the problem is. At least I know how to fix it. And right now we just want to get it to work. I'm going to take this nav mesh and I'm going to raise it up so it's kind of more on the level with the origin of our enemy. So if I click the navigation mesh instance and then I go over here to the navigation resource and click that to expand it, remember we can click bake to bake the nav mesh, and I'm going to raise this up. The height, if you expand the cell section, I'm going to raise this up to about 0. I'm having some difficulty. Let's go a 0.75 or 0.8. It will not let me enter it, so I'm just going to clicky click there. 0.75. And now if I rebake it, you can see that it's a little closer to the player's. Let's hit 1, 3 on the number pad, and you can see, what? I have an issue. My nav mesh has got a slope to it. And I think that's because, well, our nav mesh has a really low resolution. And if you notice my ground plane, the grid is not lining up properly with the ground. So I bet I rotated my ground at some point here. Let's go back to the level and my ground box. And if I go to the transform of my, whoopsie, expand that. Yeah, see, at some point I rotated this. So let's set all these to 0. Ooh, look, my mesh lines up. My grid lines up way nicer now too. Okay, so back to the nav mesh instance. Good, and let's bake again. Well, there we go. At least it's flat. I hit 3 on the number pad to look. Yeah, I want it more in the middle, so I just want it the same as about our origin. So let's set this to, having troubles here, clearly. Let's set this to 8. It's a little higher. 9? Anyway, that looks good. I'm using 0.85. Does it work? Are you going to nav now? Yay! Okay, that fixed it. Good. Now, don't remember, they attack. They go way back to their... Whoa, that was far. Why'd you go so far back? Attack again. You're always going to the origin? Okay. So he's somehow obviously messed up in the enemy script here. The return position, the return target, and where do we set that? We set that never. We never set it? Oh, we never set it. So he's always going back to the return target, which is just an empty vector 3 or null or 0, so that's going to be the origin of the whole level. Okay, so we need to set the return target when it attacks. We set the attack target. We set it to attacking. We also want to set the return target. And we'll set that to our current position before we've started attacking. So that'll be I'm talking about the enemy here, right? So that'll be our global transform.origin. Now, it should not jump back to the origin. He should just jump back to where he attacked from. Yeah, that's good, right? We still have the vibrating problem to deal with. We'll deal with that at the end. Because the other thing I want to do, which will also make it easier to tell if everything's working, is I want to change the color when they're attacking. Let's make them red, angry, red. So they'll go from their weird goblin-y, zombie-ish green color let's go to the mesh instance, and I'm going to save this mesh here. So if I click the down arrow beside the material on our enemy's mesh instance, I can save this as their default color. Let's just call this enemy default. So that's our enemy default resource. We should probably say material because TRS is a text resource and it could be all sorts of stuff. So, and let's make a new one. This time it's going to be red, so we'll change the albedo to a bright red color. Oopsie. And we'll save that one as well. And we'll save this time, instead of enemy default material, we'll call this the enemy attack material. And why don't we make a resting one as well? Just, it'll be visually helpful for debugging. So let's create a new spatial material. Again, albedo. This time we'll set it to some like orangey yellow color. Sure. It's got a blue hint to it, right? Because of the sky. And we'll save that one as well. And this time we'll call it enemy resting material. Okay, now I'm going to save that. Let's go to our enemy script. We're going to need to load all of these. So at the top here, I'm going to create a new variable called the default material. And it's going to equal, we're going to have to load that resource. And the nice thing here is I can just drag and drop these materials into this method. But if I'm going to be reorganizing, that's going to be annoying because this is a hard-coded path, and unfortunately it doesn't update. At least it didn't seem to update when I was doing some tests. So for now, I'm actually going to right-click and create a new folder called enemy. And let's just put these 3 enemy materials in there for now. And in the next video, we'll clean all this up and we'll drop the rest of the enemy stuff in it, and I can kind of talk a little bit more about reorganizing and what Godot does to update all the references to where things are. So let's get rid of this and the quotes. And now if I drop the enemy default material into there, good. I got to add my closing parenthesis. And we'll also add an attack material. Meh. And we'll load that. And we'll also add a resting material. And we'll load that. Okay, so let's drop the attack material in here. And let's drop the resting material in here. And now we just gotta change the material. Let's start by, in our ready method, which is not doing anything right now, let's set the default material. So if I go to the mesh instance in the inspector, we're gonna have to get the enemy's mesh instance, and we're gonna have to set its material. Script, ready. So let's get our mesh instance. Mesh, there's our mesh instance, and let's dot and see what we can find. So material, what do we got? Material override. That's not what we want. We want, I think, set surface material. That's what we want, set surface material. So this variable takes 2 values. One of them is an integer, which indicates the index of the material, the mesh's material. So you see this 0 here. Meshes can have multiple materials, and although everything we're dealing with, and probably will, is only going to use one of them, and since this is 0 indexed, it's going to be the 0 material. And then finally we give it the material. So in this case, we're going to give it the default material. Actually, you know what? It starts with the default material, does it? Did we put it back? No, it's yellow. Okay. So let's make sure it goes back to green when we run it. Did it work? Yep, spawn green. Good. That was easy. So we're in the enemy's script now. Let's copy this, and we're going to set the material when it is attacking. So when a player enters the attack radius, we set it to attacking, and we're also going to set the material to the attack material. Good. And when we've reached the attack target, returning, when we're finished returning and we start our resting timer, let's set the material to the resting material. Good. And let's see if we get that. Attack. Rest. Oh, it's cool, isn't it? Attack, rest, attack, rest. Okay, look. Oh, you can see our big problem here. See how that guy's stuck attacking. That guy's resting. Oh, well, clearly we never set them back to the primary material when they're done resting. But we got some issues there we need to fix. So when they go back to seeking, right here, when the attack timer is up, we'll set the material back to the default. And now they attack, rests, green again. Good. So here's the problem. This vibrating stuff happens. They're red. That means they're still trying to attack. They're still trying to reach that attack position, but they're interfering with each other. So we need to tell the enemies when they're attacking not to collide with each other. They'll just go right through each other when they're attacking. So let's create a method in the enemy script up here before all our signals, before update path. Yeah, here in kind of our move and attack, just below our move and attack. And we'll call it collide with other enemies. And we're going to take a Boolean variable, and it's going to be should we collide. So if we send this false, which we'll do when we're attacking, it will no longer collide with other enemies, and then once it's done, it will start colliding again. So how we need to do this is we need to, oopsie, in the enemy here, we need to set these with code. So right now the enemy is on the enemy layer and it collides with other enemies. It detects other enemies. And we want to turn both of these off. We want to turn this off so it doesn't collide with other enemies. And we want to turn this off so other enemies don't collide with it. Actually, I don't know if we need to turn that off. Let's start with just turning off the mask so that it no longer detects other enemies and it won't collide with them. What's important now is we can't actually refer in our code to the name, to enemy here. We have to refer to the bit. And this bit is bit 2. That's the important part. Oops, let's go back to our enemy script. And we're going to use the method set. Add my colon there. Set collision mask bit. So you can see here we need to give it the bit and then the value. So the bit we said was 2. And the value is going to be whatever we give it. Should we collide? So when we want to turn it off, we'll send false to this place, and when we want to turn it back on again, we'll set it to true. So let's copy that. So when we're attacking, which happens right here with all the other stuff we do, we're going to set collide with other enemies to false. And we're going to have the same problem when it's returning. It's going to get stuck in the return state. If it's colliding, it can't get back to that return position. So we're going to set it back to colliding only after it starts seeking again, right here. So we'll set it back to true after it turns green. I guess we could set it to true after it starts resting, right? Because once it starts resting, it's reached its place. Let's do that, because we don't want it sitting there resting, overlapping with a whole bunch of other ones. So where do we set it to resting? We set it to resting right here once it's reached its return position. So let's try that. Okay. So we have, there we go, attack, attack. Yeah. Okay, so we're still having problems here. Like that guy's stuck attacking. He was stuck red. Why are they red, right? Oh, they're red because they're not finding their return position, because they only turn yellow once they find their return position. So I think that's probably why. I just wanted to turn off both. For the enemy, I wanted to turn off both the mask and the layer they're on. So let's go back to the script and we'll do both of them. So we're going to set the collision mask bit, and we're also going to select the collision layer bit, and we're going to turn that off or on as well. So when it's off, they're not going to collide with anything. Okay, so well, that looks good. Let's do the real test, and let's test it with a bazillion enemies. Okay, ready? Ready? Here we go. That's it's working, I guess. Hilarious. Okay, I love it. Pew pew pew.